Might Proxima b someday be another Earth-like planet? These are speculations that everyone keeps making. The journey for an alternative habitable planet and extraterrestrial life on various planets fascinates people. There have been various theories, and the fact that signals have come from Proxima b makes people believe there is more to it. Despite these various signs, we still can't determine whether these are messages from the planet or simply echoes of our own signals. Often, these signals turn out to be dead ends in the search for extraterrestrial life. Specialists want to determine if extraterrestrial life exists by checking whether these signals are truly from Proxima b. Recently, the James Webb Space Telescope detected artificial lights on Proxima b. If you're excited about learning about other planets and our progress in finding extraterrestrial life, subscribe to our channel. We create content about space and discuss advancements in science. If you enjoy this content, leave a comment below and share this video with your friends. Now let's dive back into our video. Proxima Centauri, located about 4.2 light-years from our nearby planetary system, is a red dwarf star classified as a G-type star. Thus, the star is known as Proxima Centauri. It is the closest star to our Sun and solar system. It was named Alpha Centauri by Johann Bayer in 1603. Based on the stars rising around noon when a few celestial bodies like the Moon and Sun were in a straight line. Proxima Centauri is also known as Alpha Centauri or Alpha Centauri A. It is a single star system with 4 main forces of destiny aligned in a straight line. Proxima Centauri is at the center of this system. Apart from the 4 stars, there are 2 faint dwarf stars, Alpha Centauri b and Alpha Centauri c, which make up most of the mass but are too dim to be seen with the naked eye. The system is located 23 degrees away from the famous Big Dipper asterism in the constellation Centaurus. Although Proxima b is a rocky planet, there is still hope that it could harbor extraterrestrial life. The search for other life forms has led scientists to Proxima b. They believe that similarities to Earth's size and its distance from its small star make it a viable candidate for planets that could support life. While this is all speculative, there is hope that there may be some truth to these hypotheses. There is still much to learn about Proxima b and its orbit, so stay tuned to find out more. You can also check out some of our other content related to extraterrestrials. Do you truly believe there's life out there? Leave a comment below. What captivates many people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet orbiting an M-type star, with a mass estimated to be 1.27 times that of Earth. Proxima b takes 11.5 days to complete an orbit around its star. It was discovered in 2016, and many researchers are studying it. Although Proxima b resembles Earth, specific features make it less suitable for life. For one, the planet is too close to its star, which means it receives intense ultraviolet radiation. It is estimated to get many times more radiation than we do from the Sun. This radiation is so severe that it strips even the lightest hydrogen atoms over time, doing the same to oxygen and nitrogen. While many argue that Proxima b should be habitable because it is at a similar distance from its star as Earth is from the Sun, there's more to it than meets the eye. Distance alone doesn't determine whether there is water on the planet or any evidence of an atmosphere conducive to life. Earth's atmosphere makes it habitable, while Mars does not have the right atmosphere for climate regulation or a water-friendly surface to shield living organisms from hazardous space conditions. If you're still with us and haven't subscribed yet, take a moment to hit the subscribe button. It makes it easier for us to keep creating content you'll love. Now, let's see why people believe the James Webb Space Telescope will help us determine if there is life on Proxima b. The James Webb Space Telescope was launched in 2018 after delays since 2011. Numerous adjustments were needed to ensure it provided accurate images. During its development, researchers explained that if a planet like Proxima b could absorb light from its star, it could also emit it as infrared light. The James Webb Space Telescope was specifically designed to observe infrared light. It can capture images of this light on a planet's surface and look for patterns that might confirm if the planet has water or an atmosphere. One reason space telescopes are preferred over ground-based ones is that, by being above the atmosphere, they avoid the atmospheric distortion that hinders deep space observation, giving a better view of the cosmos. Another advantage is that weather changes on Earth don't affect them, ensuring astronomers get clear readings. The main downside of a space telescope is the high cost of repairs if something goes wrong. There have been instances where a minor flaw in a space telescope required a full mission to fix it. These costs make observing planets like Proxima B challenging with the James Webb Telescope, as we have no option for repairs now that it has been launched over 1.5 million kilometers away, farther than any human has ever traveled, making rescue missions impossible. Unimaginably, the James Webb Space Telescope includes a bigger mirror, permitting us to see back to the start of the universe almost 13.7 billion years ago. The further away an object is, the further back in time we get to see it. This is because it takes time for light to travel from an object back to us. The James Webb Space Telescope's ability to observe the universe in longer wavelengths and infrared light means we can see more distant galaxies with greater resolution than was previously possible. Subsequently, observing planets like Proxima B has become easier, as it pushes the light out of the visible range and into the infrared. Tabor and Bend have developed a scale for artificial light as a minuscule fraction of how the sun illuminates and considers the day side of the planet. At 0%, one would expect that the planet's night side is completely dark. At 100%, it means the planet's night side is as bright as the day side. There has been theoretical work on Proxima B using this type of light, and most experts believe it's similar to Earth's early days. Studies show that if the night side of Proxima B is illuminated to 5% of the average daytime brightness, the James Webb Space Telescope could detect the artificial light by 85%. If the illumination reaches 9%, the telescope would detect up to 95%. Even though 5% light may seem a modest number, we're discussing the light from a star as distant as Proxima Centauri, compared to our Sun. It's 600 times dimmer. Yet we still receive plenty of light from our star. This means that even at 0.1% of brightness, we are still reflected in the stellar light. In summary, if Proxima B has any civilization emitting light like Earth, the James Webb Space Telescope wouldn't be able to detect it unless the stars were significantly brighter. This scenario is unlikely, given that Proxima B orbits so close to its host star, potentially being tidally locked. This means one side of the planet always faces the star, while the other remains in perpetual darkness. A civilization living on a tidally locked planet would likely need to focus on lighting systems and use very bright orbital mirrors to reflect sunlight from the day side to the night side of the planet. These are hypotheses advanced by Tabor and Bend, and there is still no evidence to prove their validity. Earth's illumination is visible from space and is known as airglow. Many people wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when seen from 300 miles above its surface. Airglow occurs when particles in the upper atmosphere emit light to dissipate excess energy. On Earth, airglow can happen when molecules and atoms get ionized by sunlight and capture free electrons. The glow resembles an aurora, except auroras are driven by high-energy particles from the solar wind, while airglow is driven daily by solar radiation. Since the James Webb Space Telescope's launch, scientists have been wondering if it's sufficient to observe distant planets in faraway universes. Although it's the farthest space telescope launched, it still provides limited data needed to find planets with life in other worlds. There have been discussions about developing larger and better telescopes. These projects are often expensive and involve a lot of trial and error. The James Webb Space Telescope's launch was delayed by 7 years due to these issues. Thus, it is crucial for most researchers to develop better technologies that can be launched further into space. Despite this, the James Webb Space Telescope's results are promising. Soon we could know if there is life on Proxima B and other planets. While work is still ongoing on additional telescopes, it's hoped that the completion and launch of the HabEx exoplanet observatory will revolutionize space exploration. The estimated completion time for HabEx is 2035, with a launch shortly after. HabEx will be sensitive to all planets in the universe, and its primary objective is to search for Earth-like planets. Its cutting-edge technology will allow it to measure the spectra of most planets and determine if they are habitable. HabEx is also believed to have a wide range of astrophysical capabilities, which will enable it to study the earliest possible epochs in the universe's history, gather data, and understand the life cycles and deaths of massive stars, as well as the factors that support life as we know it. Though HabEx is still in development, The technology used to create it will allow it to study Earth-like planets with such precision that images from these planets will be incredibly clear. HabEx will be sensitive to ultraviolet, optical, and infrared light. The concept behind HabEx is highly compelling and will transform space exploration as we know it, provided it can be realized. If it succeeds, space exploration will undoubtedly change, and people can look forward to more information about extraterrestrial life on other planets. It will also provide a clearer picture of Earth, allowing us to look back at the planet's history and the changes that have occurred in our environment. LUVOIR is a smaller version of a telescope but builds on our experience with the James Webb Space Telescope. It has UV capabilities and is viewed as the next observatory telescope to be used by most astronomers. Space experts aim to launch LUVOIR simultaneously with HabEx. The large UV/optical sensor will greatly enhance space exploration. Studies conducted with LUVOIR show that it will be able to understand what makes Earth stand out from the rest. Some observations have been made of 28 Earth-like planets, and the results have been promising. With such telescopes produced, generating insights about planets like Proxima b can become clearer. Although the James Webb Space Telescope has made significant progress in discovering new information about Proxima b, much remains to be improved. Better visibility of other planets and the ability to detect atmospheres more accurately are needed to help answer whether extraterrestrial life exists. It will also provide further insights into the planet's history and examine the changes that have occurred over the years. Ever wondered what would happen if we found extraterrestrial life? Don't worry. We have videos on our channel discussing this and much more. Subscribe to our channel and hit the notification button to be alerted whenever we post new content. Is there life beyond planet Earth? The debate about life on other planets has been ongoing for a while now. Many people believe that we are not alone in the universe. There have been theories and claims made for decades, but whether we will ever know if life exists on other planets depends on the type of research we conduct. Scientists are trying to ensure that we have more space telescopes orbiting Earth and other planets. However, these telescopes need to be more advanced and look beyond infrared lighting to provide better answers about extraterrestrial life. For now, we watch with bated breath as we hope to determine whether our neighboring planet, Proxima b, harbors any life. To learn more about the James Webb Space Telescope and Proxima b, please subscribe to our channel. We post videos regularly, review telescopes, and examine the evidence of Earth-like features on other planets as we search for life beyond our world. Recent advances in astrobiology have renewed interest in the potential for life on exoplanets, especially Proxima. Experts are exploring the planet's surface features and composition to better understand its habitability. For example, studies focus on identifying the presence of liquid water, a crucial ingredient for life as we know it. Moreover, the planet's atmospheric conditions are a topic of interest. Scientists are examining how its proximity to its star affects temperature fluctuations and atmospheric conditions. These factors could determine the viability of habitats, should they exist. The prospect of biosignatures of life, such as specific gases in the atmosphere, has become increasingly important. Researchers are developing models to predict what profiles of these signatures might appear on Proxima b, enhancing the search for extraterrestrial life. Interdisciplinary collaborations among astronomers, geologists, and biologists are essential for refining our understanding of potential life on exoplanets. These teams aim to devise comprehensive strategies for future observations, utilizing both current technology and innovative ideas for upcoming missions. As we refine our search techniques, excitement around Proxima b continues to grow, highlighting humanity's quest to explore the universe and uncover the mysteries of life beyond Earth.